Welcome to AP Statistics with Mr. Walton. Today we're going to talk about Chapter 2 review. Got a target areas up here for you. Please look over these. Make sure that you understand what we're talking about. Go over the summary at the end of your book. Don't forget that another name for the cumulative relative frequency graph is also the ogive. But otherwise, these are great. Right there, what you need to know, as well as look over your quizzes. Please. All right. So first, let's check for understanding with a normal distribution type of problem. Remember, a normal distribution means that our beautiful graph should be approximately symmetric. So sketch the density curve that describes the distribution of scores on the quizzes. So I'm going to make an approximately symmetric distribution with 83 and then 1, 2, 3, then 1, 2, 3 because I have 3 standard deviations above and 3 standard deviations below when we're sketching. So we have our beautiful 88, 93, 98. We have a beautiful 78, 73, and 68. When it says for number 2, and that's our picture, you guys. You don't have to do the big lines like they talk about from the book or we've seen Mr. PhD do. We just need you to get a simple graph that has 6 standard deviations, approximately symmetric distribution that allows us to use our 68, 95, 99.7 rule, which is the empirical rule. Remember, the other name for this is the empirical rule. All right, so next up says what percent of the scores are between 78 and 93? So if I'm looking 78, this is my mean at 83, and 93 is here, so I think I said 98, I'm sorry, 78 and 93. So then we're talking this amount in yellow is 68% because that's within 1 standard deviation. And then this amount, okay, gets added in there. And if we think about it, it has to be another 0.135. All right, and there's a couple of ways you could have gone about getting that. You can calculate that we have 95.95 minus 0.68, which is equal to our beautiful 0.27, and I'm taking half of that, and that's my 0.135, or you could know it. All right, either way, we add those two together, and we get 0.815. So for our final answer, we have approximately 81.5% of the scores between 78 and 93. Next up, what's the probability that a student scores greater than a 90 and earns an A? So, what are we looking for here? So first, let's define that X is a quiz score so that I know that I'm using this for the rest of these problems as well. Then I'm going to make a picture. You guys remember the 4 things I want, right? There's my 83. Here's my 90. Probability statement. Probability that X is greater than 90 is equal to how much? Okay. All right, so once I have that, then I am going to find out that I get 0.0808. So I'm going to say about 8% of students' quizzes are A's. Also, here's a reminder, normal CDF lower bound, upper bound, mean, and standard deviation. That's right. All right. Next up, what percent of scores fall between 71 and 95? Okay, so we've already defined X. We know that 83 is here. We have 71 and 95, and I'm looking for in between here. So that's the probability that 71 is less than X is less than 95. And if we calculate appropriately, we get that's about 0.9836, which means in context, we're going to come down here and say approximately 98% of quiz scores are between 71 and 95. Awesome. Now, gotta have another. What score would place a student in the 20th percentile? Remember, this means below. So making another pretty picture. Here's our mean. 0.2 is the shaded area. So then I have, what's the probability that X is less than, I don't know what my X value is, equals 0.2. Now remember, this is inverse norm, and it's area to the left, mean, standard deviation. All right, and for this I got that my box is equal to 78.79. So then I can say a score of 79 would place me in the 20th percentile. Boom. So hopefully that makes sense. Hopefully you guys are rocking and rolling and you like this. Now, we definitely need some multiple choice practice. Woo! Here we go. Multiple choice practice. Number one, the 16th percentile of a normally distributed variable has a value of 25, and the 97.5th percentile has a value of 40. Which of the following is the best estimate of the mean and standard deviation of the variable? Remember, this is system. All right, so you're going to set your systems up, and hopefully you're going to calculate appropriately and get E. E is the correct answer. The proportion of observations from a standard normal distribution that take values larger than 0.75. So here's the key. This is Z normal. So it's all about the Z scores here. All right. So that's the probability that Z is greater than 0.75 for its values, right? And if that's the case, hopefully you guys get A. So we started with E, now we got A. Now we have another little rectangular density curve. You're reading carefully. It says, what percent of the observations lie between 0.4 and 1.08? Right? So, and hopefully you make the correct calculations and you get B. Nice. Next up, the distribution of the heights of students in a large class is roughly normal. The average height is 68 inches, and approximately 99.7% of the heights are between 62 and 74. Thus, the variance of the height distribution, now that's a trick one, variance, remember? Variance is equal to standard deviation squared. So if 12 divided by 6 equals 2 is my S sub x value, because there are 6 standard deviations between 62 and 74, my variance needs to be 4C. So make sure we're paying attention to what's being asked, okay? For number 5, the mean age for our presidents, and hopefully this looks similar to something we might have seen before, and we're able to calculate where George Washington is this time, and hopefully we would get C. Which of the following statements are false? The standard normal table can be used with z-scores from any distribution. Nope, they have to be approximately normal. So that's false. The mean is always equal to the median for any normal distribution. Approximately, that is true. Every symmetric bell-shaped distribution is normal. Ooh, I don't like that word every. Okay, the area under a normal curve is always 1, and that is true. So this one's false. So where's 1 and 3? We're talking about B. All right, because remember, symmetric doesn't have to mean that it's normal. All right, high school textbooks don't last forever. So now we have a mean, a standard deviation. We're talking about how do we calculate appropriately using normal CDF, and if we do it correctly, we should get here, B. And switching colors again. Now we have another distribution. We're given a mean and a standard deviation, and the distribution of z-scores, okay, you ready? Strongly skewed to the right, so can we change the mean and standard deviation? No. Can I change the skewedness? No. So therefore, I have to keep the same thing. But it says z-scores. What's the mean for z-scores? Z mean equals 0. Standard deviation equals 1. Skewed to the right, D. All right. Now, number 9, we have an ogive, which they call the cumulative relative frequency graph. Okay? If we use it appropriately, I'm hoping you're going to get third quartile, approximately A. Closest one, 6.7. And then lastly, don't forget about our normal probability plots. Normal probability plots say we should have something that's linear. I'm thinking that we have an issue right here. That tells me that it probably is not approximately normal, but it would be skewed. C. Hopefully this helps. Make sure you review, read the book, and have a great time with AP Statistics.